Let's begin our discussion of VLANs and VTP and trunks by reviewing the basics of VLANs that we talked about back in your CCNA studies. Let's remember what life was like without VLANs. I remember back in my early days of networking, back around the late 1980s, early 1990s, instead of having Ethernet switches, we had Ethernet hubs. And we would go into a building and there would be a wiring closet on each floor of a building, much like this example on screen where we have a couple of floors. And if we wanted to separate departments that coexisted on a floor, we would need to give each department their own hub. Here, notice that I've got a switch on floor 2 dedicated to sales. I'll put an S to represent sales. I've got another switch to represent accounting. And the same thing on floor 1. I've got a sales switch and an accounting switch. And if I have this accounting computer that wants to talk to this accounting computer, well, the traffic is going to go into that floor 2 switch, down to the floor 1 switch, and then out to the accounting computer. If I want to talk between accounting and sales, they're in different subnets. Notice that they're going in to different router ports. I've got a port going into my router just for sales and a port just for accounting. If I want to go from this accounting computer to this sales computer, how do I do that? Well, my packet is going to go into the accounting switch on the second floor. It will go down to the accounting switch on the first floor. Then it's got to go out to the router because I have to route between subnets. The router is going to then route me to the sales subnet, and it's going to go up to the floor 1 sales switch, and then it's going to go out to the sales computer on the first floor. And I think it's obvious that this type of solution doesn't scale very well. I've only got 2 different departments, but what if I had 5 departments on each floor and I had 10 floors? Suddenly we have a lot of switches in this building. Fortunately, we can take Ethernet switches and group the ports into different VLANs, different virtual LANs. In fact, let's do that with this topology. Let's have a single switch on floor 2 and a single switch on floor 1, and simply take the ports on those individual switches on each floor and carve them up into separate VLANs. Things are already starting to look better with this topology. We don't have as many switches on each floor of our building. We're able to support multiple subnets or multiple VLANs on a single switch. This accounting computer, it's going into a switch port that is part of the accounting VLAN. This sales computer, it's going into a port that's part of the sales VLAN. And if I wanted to send traffic from this sales computer to this accounting computer, what we could do is we would go into our sales port on the floor 2 switch. And still we're assuming that we have a port that's going out for sales and a port that's going out for accounting. We would go out of the sales port down to this switch. And again, we've got an outgoing port for sales and a port for accounting. We would go out of the sales port down to the router because we have to route between VLANs, between subnets. We would go back into the floor 1 switch, and we would go out to this accounting computer. And by taking these switches on each floor and carving the ports into separate VLANs, we're getting some security. We get VLAN separation. We get different broadcast domains. In fact, we can often think of these terms synonymously. A VLAN typically equals a subnet, and that equals a broadcast domain. A broadcast seen in the accounting VLAN, it's not going to be seen in the sales VLAN. And hopefully you can see where this discussion is going based on your CCNA studies. Even though we've got multiple VLANs on a switch, which is fantastic, we still have a little bit of a scalability limitation here because we're having to dedicate a switch port to interconnect with another switch just for the sales VLAN and another port to connect with another switch just for the accounting VLAN. Later on in this module, we'll talk about the formation of a trunk. Remember what a trunk does from your CCNA studies? A trunk is going to allow us to have a single connection between switches, and that single connection is going to be able to carry traffic for multiple VLANs. What we're going to be able to do is replace these 2 connections with a single trunk connection. More on that later though. For now we're focused on VLANs. And let's take a look at a Cisco Catalyst 2960 series switch and see how traffic might flow through that switch if we carved the ports up into a couple of different VLANs. Let's say that I've got a PC attached to this port of my Cisco Catalyst 2960 series switch. And let's say that I've got a server attached to this port. And imagine that these devices are in different subnets. We'll say that this PC is part of the 10.1.1.0/24 subnet, and the server is part of the 192.168.1.0/24 subnet. We're in different subnets. We have to route to get between subnets. No problem. We can attach a router to this layer 2 switch, keeping in mind that some of our Cisco Catalyst switches are multi-layer or layer 3 switches. They can do routing internally, but here we're imagining that we've got this router attached. And this router can go into the switch with a single trunk connection. In other words, traffic for multiple VLANs can flow over that single connection. This is oftentimes called a router on a stick or a router on a trunk connection. And it's going to allow us to route between ports that belong to different VLANs on this switch. Let's say that these 12 ports are part of VLAN 100. And these 12 ports are part of VLAN 200. And let's remember why we might want to have a VLAN separation. It can help us with performance to break up broadcast domains. It can help us with security. That way we don't have somebody on our VLAN doing a packet capture of unknown unicasts, multicasts, and broadcasts on our subnet. They're not able to see and capture those packets because they belong to a different VLAN, a different broadcast domain. Those are a couple of design reasons, performance and security, that we might want to break things up into different VLANs. But let's ask the question, how does the PC talk to the server? They're in different subnets. Well, here's the way the packet flow goes. This PC is going to send a packet out destined for the server. It's going to go into the ingress switch port. It's going to flow across the switching fabric, in other words, across the switch backplane, over to this trunk port, where it's going to flow down the trunk to the router. The router's going to realize that this packet needs to go to VLAN 200, and it's going to send it back up the trunk, where it's once again going to flow over the switch backplane and go to the egress port this time, and we're going to go out to the server. That's a way that even with a layer 2 switch, we can have traffic flowing between different VLANs, between different subnets. And now that we've talked about VLAN operation in theory in this video, in our next video, let's review how we configure and verify VLANs.